ィジカルな世界に維新を起こす。
So I'm a computer scientist. I got my master's degree from Stanford and then joined Google in the Bay Area. I'm kind of like frustrated about how the physical world works. So I think the physical world is not very efficient, like comparing to the digital world. I haven't seen a industry that is so big like manufacturing, but then in terms of the IT, that it's not that advanced. And so there are many things that we can do in that space. If we can make a change, that's already huge.
コンピュータービジョンプラットフォーム for Manufacturing and Smart City Applications PowerArena PowerArena Corporation Ken Law。
それではLAUNCHPADスタート。
3, 2, 1, launch.
Konnichiwa, I'm Ken from PowerArena. So the technology company and also the mass media tell us that this is the factory of the future. Everything is automated, made by machine, and no humans are there. We can even turn off the lights. So Elon Musk really tried to build this, but failed. He learned that excessive automation in Tesla was a mistake, and now there are a lot of people working in the Tesla factory now. So Apple tried to do that as well, but also failed. And now the expert consensus is that total automation is more like a fiction instead of the fact. And that's why while so many companies are working on machine, robotics, and things like that, we are focusing on human and how to make the human and the assembly line more productive. It's actually a very, very expensive problem. Like 40 people working 24 times 7 is costing $1 million US per year. But how do we manage that? It's still based on paper, pencil, and stopwatch. And so it is industrial engineer doing the motion study. And that's why they can only spend 15 minutes per line per month, and the data is always delayed. So imagine there's a way that we can kind of like magically capture and understand what's going on in the assembly line. So in that case, we have 100% of the data. We have it in real time. It's not biased. And it creates a new way to do Kaizen, continuous improvement. Well, there's a way to do that. So what we're doing is we use typical webcam connected to a deep learning video analysis. And we can understand a lot about what's going on in the factory. So for example, here we understand, for the worker, which tray they're picking things up, which motherboard they're working on, and the time, for each steps. So we collect a lot of information. But how to use those information, right? So this is an actual example. So assembly line is organized by workstation one by one over here. And so our clients can go to any one of them and understand what's going on in real time. So you see the number 26 here. When this guy drop an item, it goes from 26 to 27. So the AI is kind of working, but that's not how people are going to use our system. So the most important thing is we detect a bottleneck in the line. So as you can see over here, in one particular workstation, one process, it takes a lot more time than other lines and then other workstation. So what the industrial engineers can do is, find out what's going on. So we select all the problematic instances. Usually it's not because the worker lazy, they're actually people hardworking. So the IE can take a look and say, hey, they are actually, for this particular one, they're actually adjusting their workstation. And that's why they're taking more time than usual. So what they can do is, on the bottom right, they can mark the reason. And this is called root cause analysis. They are doing, after looking at 20, 30 videos and doing this kind of analysis, we can, find out the root cause of the problem, which is shown over here. So it turns out that, two causes are actually contributing 60% of the problem. So they can concentrate on working on those two. So what's the result? So this is, so the y-axis of this graph is called unit produced per hour. This is, the number of things that assembly line crunching out in an hour. So this is a real, productivity measure. So this is before using PowerArena, while using it and collecting the data. And this is introduced to actual improvement on the assembly line. So they improve the productivity by 5%, and they're aiming for 10% really soon. So which translates into 50K US saving. So we are very focused on the electronic manufacturing. Number one is, Foxconn, everybody know. So now number one, number three, and also number five are our clients right now. So we pack really powerful AI into a single box. And we already have some, we studied motion, right? We already have some motion that we already know, like picking things up, putting things down, and inserting things. If there's something that we haven't seen, you can build your own AI. So you can build your own AI recognition model. And because of the build your own AI, our partner is now extending our solution to many different applications. So for example, this is the garment industry. They're looking at the cutting bed. And if the cutter, I mean the green one, if the cutter is idle for more than 15 minutes, they want to know why. This is making dumpling. And they want to compare the performance of different workers. This is looking at the number of people waiting in line and the number of taxi so that we can calculate the wait time for different taxi stations. This is the border. So when the car comes by, we automatically trigger the immigration process. And finally, this is we understand the defects of the pipes so that we can do the maintenance. So we are extending to other many verticals now. So 10% of the people are still in manufacturing, but hopefully the future is not about machine replacing man, but they're actually working together to deliver a better factory of the future.
Game over.
Okay, time's up. Thank you very much.
Thank you.
Thank you.